Hello, everybody, and welcome to today's webinar presentation titled Accelerate Feature Engineering for Machine Learning Models with Snowflake and AWS, brought to you by Snowflake.
Hey everyone, welcome to AWS Dev Day. This session is on Accelerate Feature Engineering for Machine Learning Models with Amazon, SageMaker, and Snowflake. If you guys have any questions, please fill in the Q&A box onto the right of On24. We will also have many resources in the On24 section for you to download or to attend. This recording will also be sent live to all of you after 24 hours of this. Now I'll pass it on to Andreas to go on with the session.
Thank you, Jackie. Thank you everybody for making some time and joining us today to cover this very interesting session on accelerating feature engineering with Amazon SageMaker, specifically Data Wrangler with Snowflake. So today's presenters will be Dylan Tong. He is the partner technical lead for AI augmented analytics at AWS. He works with partners to develop joint solutions in this domain to elevate customer value and experiences. We've been working together on solutions for a couple of years now, and he brings over 19 years of industry experience to the table. I'm Andries Engelbrecht. I'm a principal partner solutions architect at Snowflake, working with AWS, building joint integrations between AWS services and Snowflake and joint solutions for our customers. So what we'll be covering today is an overview of Snowflake data sharing and the Snowflake Data Marketplace, as well as the MO workflow with SageMaker and Snowflake. And then we'll dive into SageMaker and the Data Wrangler overview. And then we'll do a walkthrough of data preparation and feature engineering. We will also have Q&A throughout the session. And as Jackie mentioned, that will be available in the On24 Q&A box. At the end, we'll also wrap up with a Q&A session. So the specific topics that we'll cover today is learn how to securely share data across Snowflake accounts, and then how to bring third-party data from the Snowflake Marketplace to enrich your internal data sets. Then we'll see how to connect SageMaker Data Wrangler with Snowflake, and then leverage the pre-built analysis and feature engineering capabilities within SageMaker Data Wrangler. So let's look at Snowflake data sharing in the data marketplace. So in the center of this diagram, you'll see your Snowflake account. So one of the things that you can do is you can access data within the Snowflake Data Marketplace, and we'll showcase that in a minute. And you'll get access to data and service providers from over 150 that's already there. And the value of this is as soon as you have access to that data set, it'll just show up in your account. And as soon as they update the data on their side, it'll automatically, the freshest data will be available within your account. And then similarly, what you can do is you can set up direct shares with other Snowflake customers, and you'll be able to share data from your account with other Snowflake customers. And similarly, they can share data directly with you as well. And you are even able to set up reader accounts to be able to share data with companies that's not yet on Snowflake. So it'll actually have a Snowflake account that actually is associated with yours. And then lastly, what some customers have done is they've even been able to set up their own private data exchanges where they can administrate this ecosystem with, different suppliers, customers, etc. within their environment. Moving forward, we will actually look at the machine learning workflow with SageMaker and Snowflake. Typically, the workflow will consist of doing data preparation, data acquisition, and then doing feature engineering, and then going into training, as well as then after that deployment of those trained models and the ability to monitor and manage those models. Today, we're going to mostly focus on the data preparation and feature engineering portion of that. And what you'll see is in this diagram, the blue sections is areas where Snowflake is heavily leveraged, and then the orange areas is where SageMaker and a broad portfolio of services within SageMaker is actually used to do that. When it comes to data preparation and feature engineering, as I mentioned, you can look at using data sharing and a marketplace to enrich your data sets. You can use ANSI SQL within Snowflake to make that available. And then further, we have a unique feature called zero copy cloning, which allows you to make clones or copies of your full production data set with actually not having to actually copy the data, but just make a clone of the metadata itself. And then you can make that available for machine learning and give data scientists the ability to actually make changes to the data without impacting your production users. And then we'll go into Amazon SageMaker Data Wrangler, and Dylan will cover that in a lot more detail. There is a lot of feature-rich functionality to help with data preparation and feature engineering. Once that data is available, it'll actually be going into training, and there's various options available with Amazon SageMaker to be able to do that. And then once the model gets deployed, you have two options of providing access to those models from Snowflake. The first is you can do bulk inference, and then you just do the inference at bulk, as it says, at a whatever by time basis you need, and that data can then be loaded back into Snowflake. Alternatively, there's also the option of actually deploying a model endpoint, and then that can be called through Snowflake external functions for the API gateway to those endpoints. So it'll look like a user-defined function with Snowflake, and in real time be able to do those inference calls against the machine learning endpoint. Additionally, SageMaker also offers capabilities around monitoring and managing machine learning models. And with this, I'll be handing over to Dylan.
Thanks, Andres. Hey, everyone, this is Dylan Tom from AWS. As you can see, there's a broad set of capabilities in Snowflake and SageMaker. Today, we're going to focus on introducing you to Data Wrangler for Snowflake, which was just released last month. To summarize, integration makes it easier for you to automate the transformation of data in Snowflake into ML data sets, which you can then train and deploy models on Amazon SageMaker and benefit from the full range of MLOps capabilities. So Data Wrangler, it's a fully managed service within SageMaker, and it's designed to enable you to build these ML data prep flows with low code. We've found this topic to be practical for many of our customers. We often hear from our customers about data challenges in machine learning and how they encumber them in their AI implementations. These challenges include data management, wrangling, and how to get a broad set of tools to interoperate as a well-designed data architecture. And as you can see, this sentiment is echoed by industry analysts and experts. Today, I will show you how we can alleviate some of your pain. We'll see the Snowflake Data Wrangler integration in action, and we'll do this by building a loan default risk model on data derived from the Lending Club. We're going to do this as part of a data-centric machine learning process. That is, we're going to improve model performance by focusing on improving the quality of our data set. In practice, feature engineering is often the fastest path to big gains, and I aim to arm you with the right tools and process. In this demo, we're going to acquire potential features, first with the help of Snowflake data sharing capabilities, and then we're going to engineer a data set using Data Wrangler. Then we'll train a model using Amazon SageMaker Autopilot. This is a fully managed tabular auto ML service. It's going to help automate some of the feature engineering involved, but the biggest benefit for us in this case is that it's going to take the brunt of the model-centric optimizations like algorithm selection and hyperparameter tuning so that we can focus on the data-centric approaches to improving our models. We'll then evaluate the models, and then we'll demonstrate how we go through an iterative process to improve on the model. We're going to then acquire some new features from the Snowflake Data Marketplace, enrich our data set, and as we re-engineer this augmented data set, we're going to then retrain another model, we'll reevaluate, and at some point, we'll have a model that's ready for production, and we'll provide you some guidance on how you can deploy it as an Amazon SageMaker pipeline. So in this demo, Andres is going to play the role of the analyst, and I will be the data scientist. Let's get started. So Andres, I've been tasked to build a loan default prediction model. Can you provide me access to our loan origination data?
Certainly, Dylan, let's start looking at this. So in this case, we are looking at this financial services use case with different types of lender data. So what we have is we have a database within Snowflake that we already aggregated a bunch of the lender data and some outcomes around that. So we can just go and look at what this summary information looks like. And what you'll see on this is that it has a loan ID and the amount, and then various other types of information that's available in that. So what I'll do now is I'll actually go and create a specific schema within my ML lender database, which is a separate database, and I'll use that. And what I'll do now is I'm going to clone the full production set of the data from my lender data, because that's used by various of our financial analysts, and some of our business units are actually using and running reports of that live data, and I don't want to mess that up. So I'm actually going to use the zero copy cloning feature of that, and I'll create a new table within my ML machine learning lender database for Dylan to be able to use. So I'm going to go and quickly clone these two tables. One is the loan data and the application data. And now what I'm going to do is I'm working on a Snowflake account on my side, and I'm actually going to go and share that with Dylan's Snowflake account. So he will have access to the data itself. So to just simplify the demo today this is the SQL command you use to actually create a share. We already set that up. So what I'm going to do is I'm just going to allow usage on the database as well as the schema that I have on the share now. And I'm actually going to enable the AWS partner account to be able to read that. And then, so what I'm going to do next is I'll say, like, I want to make all the tables available in my machine learning lender database and schema to this share. So that will be available for Dylan to actually run analysis against that. So Dylan, now I've shared that to your Snowflake account, and the data should be available to you. So I'll hand over back to you.
Right, thanks, Andres. So now that I have access to my data, I'm logged into Amazon SageMaker Studio, and this is my dev environment for machine learning projects. From within Studio, I have access to all of SageMaker capabilities. And as you can see here, I can also run Jupyter notebooks. In today's demo, I'm going to run through an abbreviated version of this notebook. I plan to share this with the community in the near future. And also stay tuned. We have plans to run virtual hands-on workshops later this year. You're going to get an opportunity to run this notebook with us and build something similar to what we're going to create today. So the first thing we're going to do is we're going to create a data wrangler flow. And we're going to connect to Snowflake using the connector. There was a one-time setup to create this connector. I set up some IAM roles, created a Snowflake external stage, and now I can connect to my Snowflake environment. I have access to a number of databases, including the database that Andres has just shared with me. So I can preview the data and get a feel for how my loan origination data set looks like. So each of these records are individual loans, and I can immediately see there's some interesting attributes. We have things like the loan amount, the term, interest rate, the quality of the loans, and these are all potentially good features, right? They probably have some predictive signal. But on the other hand, I also see there's some attributes here, such as this URL, that probably doesn't have any predictive signal. It looks like a unique string. Similarly, things like description and title. And these are things I probably should just filter right off the bat, because they're just going to add noise when I train the model. I also see this is my target variable. This is where my ground truth data is. So we have examples, we have positive and negative examples. Here's an example of a loan that did not default and hence has a value 0. And we have one that has a value of 1, indicating that this is an example of a loan that did default. I'm going to run a query to extract the columns in my table that I believe have predictive potential. So this is going to give me a head start just by focusing on the features that matter. I'm going to run this query. You can also see that I'm using Snowflake to generate my train test split. So I'm using the sampling functionality to extract or sample 80% of my data set, which I'm going to use for training. So I'll call it loan data train. And I'm holding out the remaining 20% for testing. You can see here that Data Wrangler provides a visual data flow I'm in the process of importing my Snowflake data source, and then it automatically creates this transform here. This is just setting the data types and essentially defining the schema. At this point, I'll typically run some analysis. I want to get a better understanding of my data. I can then create reports such as histogram, scatter plots, run a table summary. So one of the things I would typically do to profile my data is get a sense of the distribution on my target variable. So let's look at the distribution of loan defaults. So I configure my target variable column name, and then I can run a preview. And it's, as expected, there's some skew, but what the takeaway is from this report is that the skew is not so bad that the auto ML algorithms that I plan to use, wouldn't be able to mitigate this amount of skew. This is going to be typical for the type of use case here, and not a problem. So I'm confident that the data set is appropriate. So I'm going to proceed with some data preparation. I'm going to create some transformations and build out this data set so that it's ready for training with autopilot. So in front of me, I have a preview of a sampling of my data set. I immediately noticed that we have a lot of columns that are of string type. And if I wasn't using an auto ML algorithm, I would have to apply some transformations. That's not a problem, right? I could do this with the help of Data Wrangler. But because I'm using autopilot, it would be able to detect, for instance, that this is a categorical attribute, and it would know to automatically apply things like one-hot encoding. However, every once in a while, there are certain columns that are, most, if not all, auto ML tools are not going to properly automatically translate. So here's an example of one. Interest rate here really should be a continuous numerical feature, and one that's unlikely to be properly translated by any auto ML tool. So I'm going to convert this feature accordingly. The first thing I'm going to do is I'm going to use the search and edit transformation. I'm going to do a find and replace on the column. And I'm going to remove the percent sign. Click on preview. It looks good. I click add to apply the change. So here's an example of a simple transform, but it's still a string type. So I also need to apply the parse column as type, and I'm going to transform or cast this column from string to float. So here's a simple example of a transformation or a feature, some feature transformations. I did it with no code. Every once in a while, you may have some more sophisticated requirements that may require some more customization. So here's an example of a minor data quality issue in our data. This column, verification status, represents whether or not the loanee had their income verified. It really is just a flag, right? Yes or no, a Boolean. But we have two values which mean the same thing for the positive case. So I want to do a bit of cleansing. This is an instance where I need to create a custom transformation. And so I'm going to use a PySpark script, which I've prepared. I'm going to copy it over from my notebook. I'm going to create a custom transform. And you can see that I have multiple options. I could have used PySpark SQL. If I don't care about scale, I could have wrote a script in pandas as well. And once I applied this transformation, if I scroll all the way to the end of this table, you'll see that I've created my new column, and it's exactly what I want. All I have to do now is drop the source column. And there it is. Applied a custom transformation. Because I'm using autopilot, there's really not much more work that I need to do with this data set. Everything else looks good. We'll let autopilot take care of the rest. The only thing that I might want to do is I can drop a unique ID. A lot of auto ML algorithms, could detect this and kind of drop the column automatically, but let's not chance it. So let's just add that transformation as well. So as I return to the data flow, you can see it's now been updated. I have these 5 transformation steps. At this point, I'll typically like to run some validation. So I'm going to perform some analysis. One of the useful reports at this stage is to run a target leakage report. So target leakage is a problem when you inadvertently introduce some information that you won't have available in production. The consequence is that you end up with a model that performs really great in development, but when you roll it out into production, it performs poorly, and you want to avoid that situation. So this target leakage report can detect if there is a leakage problem. I'm going to specify, how many features do I have, the problem type, and my target variable. And this report actually provides me a lot of information, not just detect whether there's a target leakage problem. And in this case, I'm assured that it doesn't look like there's a target leakage problem. As you can see here, it did detect that some of the features might be redundant. And this could be an exercise that I may run later on. I may look to maybe remove some of these possibly redundant features and see if that adds incremental improvement to my model. Like these features might be just adding noise. It also reports, and the good thing is we see most of our features are safe, and it also gives us some insight on predictability. It calculates the correlation between the features and the target variable, and we get a sense of the quality of some of these features. And we see some things like the issue date of the loan has some correlation. Another useful report at this stage is to run a bias report. That's going to help us detect if there's data bias that can lead to a model that, let's say, disadvantages certain demographics. If you look in this data set, there's no explicitly sensitive attributes like gender or race. However, you may notice there is a zip code, right? And there is the possibility that you may inadvertently introduce or indirectly introduce some bias against minorities through, let's say, maybe a poor collection or poor sampling of loans within minority communities. So it might be a good idea, especially for a use case like this, to just do a check and make sure that there's no bias associated with these minority communities. So to configure this report, I first specify my target variable, I specify the possible values, and then I'm gonna run the bias check against zip code. And as an example, I just select half a dozen minority zip codes just for the purpose of demonstration, and I'm gonna generate this report. And the takeaway here is that this report essentially is giving me some assurances. You may say, well, what about this? This does indicate there's bias, but that's the reason that's expected because this is a toy example. Of course, there'll be class imbalance because what's going on is I'm making comparison between just a half a dozen zip codes against all the other zip codes. So there is going to be, as expected, there's a class imbalance because of this toy use case. But what I do learn is that these other metrics that are independent of the imbalance does indicate there doesn't appear to be under any bias that we should be concerned about. So the final report that could be useful is to run the quick model report. And this report takes 5 minutes to run. So I've pre-generated it. And this quick model report samples your data set and it trains a random forest model. And it then reports on feature importance. Like based on the model, what are the most impactful features? And it reports on the F1 score. So this report could be useful to facilitate kind of rapid iterative type of development processes. Imagine I can go back into my data flow. I may decide to add some features, remove some features, and I don't want to go and run, let's say, a full-blown autopilot job just to see if my changes has any positive or negative impact, right? Instead, I can run that report. All right, so I've done some validation. I'm comfortable with the with my prepared data set. I want to now execute and process my data, so I can export this data flow. And what I could do is I can select where I want to export up to some point in that transformation flow. I want to run it all, so I'm going to select the last transformation. And you can see I have multiple options. I can export this flow as a SageMaker processing job. I could run it as a pipeline. It could be a vanilla Python script that I then run in my self-managed Apache Spark cluster, or I can even export a Jupyter notebook that demonstrates how I can integrate this flow into SageMaker's feature store. I'm going to keep it simple. I'm going to just create a SageMaker processing job. And you see that once I export, I ran the export and it generates a notebook for me. And the notebook provides all the guidance that I need to know how I create a SageMaker processing job to run this flow right here. So I'm going to kick that off. We're running all the cells up to all the above selected cells. So what's going on here is it's actually running a remote data processing job. It's not running on the compute within this notebook or SageMaker Studio. So the generated code by default is going to create a cluster that consists of 2 M5-4X larges, and of course you can change this. Typically, what will happen is you could run this code as is in a notebook, and then you'll refactor the code into a Python script, reconfigure it appropriately for your environments, and then commit it into source control. Once this processing job completes, then your raw data set will have been converted into a clean data set that we can run with autopilot, right? And this is actually the output path right here. And what you can then do is spin up an autopilot job, which is not your only option. If you, like for example, in this notebook here, you could have launched a remote training job. You could have your own custom PySpark, PyTorch script that you run as a distributed cluster. This is an example of running a marketplace algorithm. But one of the easiest ways to create an optimized model is to use autopilot. And to set up an autopilot job, all you need to do is specify the location of of the data that we just processed, and we specify the target variable, that's the lone default column, where we want to output the model, and then I can configure things like let it know that it's a binary classification problem and I want to optimize it on AOC. I kick off the autopilot job, and that takes more time than we have for this demonstration. So I've already ran an autopilot job ahead of time. Now, what will happen is once you kick off the job, it's going to run hundreds of training jobs to explore different combinations of feature processing steps, explore different algorithms, and it's going to run hyperparameter optimization using Bayesian optimization. And then it'll generate this leaderboard, and it ranks it, in this case, by AUC. As you can see, we got decent results, right? It's just shy of 0.8 in AUC. We drill in, and we also can get some model insights. We can see the global feature importance, which tell us which features are most impactful or have the most influence in this particular model. I may decide that I'm happy with the results and I could go ahead and deploy this model, but I know from experience I can do better. And I have an inkling that if I have a hypothesis that if I had unemployment rate data, I can make some improvements to the model. So Andres, do we have access to unemployment rate data?
Dylan, I don't know off the top of my head, but let me go see what I can find. Let me dive back into Snowflake. Yeah, so within Snowflake, we have the options I mentioned earlier of the data marketplace. So I'll use the our UI and go into our marketplace, and let's see if we can find unemployment data. So the one thing you can do is you can actually search by a term. So let's just see what comes up if I say unemployment data. Okay, so we have 8 results, and from past experience, I know Numa is a pretty good data provider, and the labor data atlas actually looks pretty good. So what I can do now is this looks like a good data set. I can actually click on it and actually give us a lot of different types of information. So labor cost, labor mobility, as well as unemployment and employment rate. So this looks like a really good data set. So what I can do now is I can just go and subscribe to that. So what it'll actually do is, as I create subscription, it will create a database within my Snowflake account that will mirror the data that's available from this data provider. And a really neat feature about this is as soon as they update the data, we'll actually have the live fresh data. So I don't have to go back and run any ETL processes. It will automatically just be available with my Snowflake account. So I'm going to go ahead and say get a data. And so now what we'll see is if I go back to my worksheets, I'll go back to Data Wrangler. And if I do a quick refresh, it should show up for us in terms of, and there's our labor data atlas. So now let me go in after that. Let's see what I can find within that in terms of unemployment data. So within the labor data atlas, what you'll actually will see is normally what you'll find is there may be some tables of views available. Typically, there'll be a data set table that actually gives you a description of what views are available with data sets within that. But just for brevity, what I'll do is I already dug around a little bit, and I found this specific data set called BLSA. So we can just look at that quickly to see what's available within that. And I'll just query that data set. So we just acquire that. So it'll tell us like there's different measures and different regions and, region ID. So they have stuff by state, area, and then they'll have the measure of that. So what we want to do now is maybe make it a little bit easier to consume, and we'll pivot the measure names out to actually each one be their own column. So what I'll do is I'll just create a view on top of this data set that'll actually pivot it out to give me the different columns of, employment, labor force rate, unemployment as a specific column. So it's just easier to consume. So we'll go ahead and make that available. So now the next thing that we'll do is we'll go and create a new table called unemployment data within our ML lender database. And what I'll do now is I'll take the unemployment data and actually will join that with our lender data based on the time and the state. So we at least have the aggregates across that. So we have for that time period, what was the average rate for unemployment as an example within that state. And I'll join that with my original loan data, but I'll write the unemployment data out as a table on my ML database. So we'll just do that quick join and create that table for us. So now what we've done is we were able to combine our internal data set that we've aggregated across multiple internal systems with the marketplace data. And I've created a new table for machine learning purposes. And the data set will basically look like this is because we associated that with a loan ID, and it'll give us the various unemployment data statistics. Now what I'll do is I'm going to go ahead and actually share that table to Dylan's Snowflake account, so he will have access to that as well. So Dylan, I have shared unemployment data with you. See if that helps you a little bit in your search to improve the model.
Thanks, Andres. Well, now that I have access to unemployment rate data, I'm going to augment my existing data flow. But before I do that, I might want to commit my my current data flow into source control, so I could use the Git integration, and then I'll proceed with the augmentation. So the next thing I'll do is I'm going to import my Snowflake, the data using the Snowflake connector, and I'm going to import the marketplace data. And I have a query in my notebook that I'm going to use. So I'm going to copy that over. And let's run it just as before. So I'm extracting the unemployment rate data. I'm also including the loan ID, and this is going to help allow me to take this unemployment rate data and join it to my baseline data set. And it's just a clean way for me to augment my data set. So again, it's importing the data set, it's creating the default transformation. I want to join the two. So if you recall, I dropped the loan ID column. And I want to keep I need the loan ID in order to make the join. So I can come in here and I can remove this transformation so that now I can apply the join to augment my baseline data set. So I can configure the join. We'll do a left outer join, and then we're using the loan ID. So now I have unemployment rate data added to my baseline loan data set. And the last thing I can do, again, just not to chance, depending on the auto ML algorithm, it may or may not automatically drop, may not drop the loan ID. So let's just do this manually. I'm gonna quickly drop both these keys and I'm done. So that's all it takes for me to re-engineer and augment my data set. I've added a new feature. At this point, you probably want to also do some analysis just to revalidate my data set. For example, the target leakage report is going to be helpful. So let's rerun this again and configure it. And if I'm on the right track, I'm going to expect that unemployment rate data, and it is, that it's highly correlated. And as we can see from this report, we can see that there's no target leakage, and in terms of predictive ability, it ranks at the very top, meaning that it's highly correlated to our target variable, which is a good indicator. So I think I'm on the right track. Another useful report is to run that quick model report. Remember, if I mentioned that this is useful for rapid iterations. So instead of running that full-blown autopilot job, I may want to run the quick model report. That takes about 5 minutes. So again, I pre-generated the report here. It'll sample, it'll train a random forest model. And you can see again that in terms of feature importance, the unemployment rate feature is the most impactful. And we also see that the F1 score had a significant improvement, right? When we compare this to like the baseline model here, which had an F1 score of under 0.7, we now are at over 0.78. So it looks like we're on the right track. And then, I'm ready to export this flow. We go through the same process. We process the data set. We run autopilot again, right? And then we wait on our results. So let's take a look at what the results are. So again, autopilot is going to automate the experimentation process. There's a lot of training that goes on and generates this leaderboard. And we see that our best model has an AUC score of over 0.84. So there's a substantial improvement. And happy to see we got a big win here with a little work, and I'm ready to deploy this model into production. At this, so what I will typically do at this point is I we want to generate an inference, a data prep flow for the purpose of inference. Because keep in mind that this flow right here is really a training flow. The data source is my training data set, and for production, we're going to run the raw data. We're going to have unseen data, which we also need to process right before our model could use it. So I'm going to then duplicate this, and let's call this my inference flow. So now I have a copy, and you would then commit this into source control, and I'm going to take the copy and I'm going to update my data source. And the easiest way to do that would be just to update the query. So for the purpose of demonstration, we're just going to use the test set, right, to demonstrate, just to kind of serve as an example of the production data set, right? Really, it could be any query you like. I'm going to copy this, and in my inference flow, I'm going to update my query. This also gives you an example of how you would have created a query to obtain the holdout test set, right? The remaining 20%. And then I apply that change. Let's just call it my loan data production. And now I have a data prep flow that I can include into my production scoring pipeline. I may decide to export this into a SageMaker pipeline. So as I showed you before, there's that option right here that generates a notebook that provides you some guidance of how you can include this data prep process into a SageMaker kind of ML workflow. And you'll need to do some refactoring. And once you've done that, your pipeline may look something like this, right? Here's a simple example. You have a pipeline that uses Data Wrangler to process the prep, convert your raw data into a data set that's ready for use by the model that you just trained. And we use something called batch transform, which then batches the predictions and you can then load it into Snowflake, where you can then run credit risk analysis. So this concludes our demo, and I appreciate you joining us today.
And with that, DZone would like to thank Snowflake for a phenomenal presentation. DZone would also like to thank everyone who attended today. We hope you learned something new that will help you in your developer career. Have a great day.